What about the second half of an action potential? The second half of an action potential depends upon a delayed opening potassium channel, and it depends upon closing of a voltage-gated sodium channel. So let's talk first about how we open the delayed open potassium channel. The delayed opening potassium channel, as the inside of the cell gets positive from sodium coming in through our open voltage-gated sodium channels, that positive charge building up eventually pops open the voltage-gated potassium channel, and when this is open, potassium is now free to leave. The inside of the cell at this point is around plus 30 millivolts. Remember, we have high potassium inside, low potassium outside, and that high concentration of potassium plus the equilibrium that ought to be, that is around minus 100, means potassium will be leaving. It'll leave the cell until it gets to about minus 100. So potassium leaves. Okay. What also happens around plus 30 millivolts is that accumulated positive charge over here by the voltage-gated sodium channel forces this little ball closed. So that has a positive charge on it. The inside is now plus 30, and the result is that this inactivation gate closes. So we stop bringing in more sodium. So at this point, we've allowed sodium in to get to about plus 30 and then closed the voltage-gated sodium channel. At that point, a voltage-gated potassium channel opens and potassium leaves. As potassium leaves, it gets first less positive. It passes 0 because there's still more potassium inside than out. And at this point, we have both voltage-gated potassium channels and still a few potassium leak channels. And so we have two ways for potassium to leave. So if we only had leak channels, if we only had these leak channels, we'd get to minus 70. But we have both leak channels and voltage-gated potassium channels. And so we wind up going to minus 80. We go past the original minus 70. Why don't we go all the way to minus 100? You'd think with all those channels, potassium channels, we might. Well, at this point, we have voltage-gated potassium channels open, through which potassium can leave. We have leak channels, potassium leak channels, through which potassium can leave. There are voltage-gated sodium channels, but they're closed, so no sodium is entering there. And then we also have secondary active transport that's bringing in glucose, amino acids, other essential molecules, and that is allowing some sodium in. So because we have some sodium coming in, we don't get all the way to minus 100. Instead, we get to about minus 80, and that's the combination of these two making it negative, but some sodium coming in so it doesn't get all the way to minus 100.